All right, let's do a recap. What is the standard form of a quadratic function? It is f of x equals a times x minus h squared plus k, where a is the leading coefficient. The vertex is hk, that's a point, and the axis of symmetry is represented by x equals sum h. Now let's sketch the graph. It says sketch the graph, but let's change this to standard form because that helps us with sketching. So first thing that we're going to do is factor out that 2 from the first two terms. So that's 2 times x squared plus 4x. Leave a little space there. And then we're going to do that b over 2 squared business, which is here. Let's look at this number right here. So that's 4 over 2 squared, which is 2 squared, which is 4. Let's go ahead and add and subtract that number. Then what we want to do is we want to recognize that this is a perfect square trinomial right here. Perfect square trinomial. So we're going to take out this unnecessary information right here, but we have to multiply what was on the inside of the parentheses that we're trying to get rid of. We have to recognize that's attached to the 2 that's on the outside of parentheses. So when we rewrite this as 2 times x squared plus 4x plus 4 and try to get rid of that negative 4, we really need to recognize that that's really equivalent to negative 8. So we're going to take negative 8 out. Should be a plus here. And then let's go ahead and factor something squared minus 1. Square root of that, x, bring down that plus sign right there. And what is the square root of 4? 2. So f of x equals 2 times x plus 2 squared minus 1. All right. So a equals 2. That means our parabola opens up. Our vertex is negative 2, negative 1, which is our minimum point. Our axis of symmetry is x equals h. X equals negative 2, since this is our h right here. And then we find our x-intercepts by setting the function to 1 and solving. So let's add 1 to both sides. That's 2 times x plus 2 squared equals 1. We're going to divide by 2. All right. So that's x plus 2 squared equals 1/2. Square root both sides. That's x plus 2 equals plus or minus the square root of 1/2. Subtract 2 from both sides. We get x equals negative 2 plus or minus the square root of 1/2. Now, let's write this so that we do not have a radical in the denominator. So that's the square root of 1 over the square root of 2. We'll multiply top and bottom by the square root of 2. So that's negative 2 plus or minus the square root of 2 over 2. All right. So our x-intercepts are negative 2 plus square root of 2 over 2, comma 0, and negative 2 minus the square root of 2 over 2, comma 0. Now, of course, you really do need to figure out what is that approximately in your calculator. So let me put that in the calculator. Negative 2 plus the square root of 2 divided by 2. So this one up here is approximately negative 1.3. And what about this negative 2 minus square root of 2 over 2? Minus. That's approximately negative 2.7. Right? And what about the y-intercept? I prefer using the general form for that. And the general form was f of x, so f of 0 equals 2 times 0 squared plus 8 times 0 plus 7. So we get 7. F of 0 equals 7, 0, 7. So here are our important points. We have our vertex, which we said was negative 2, negative 1. Right here, we have our x-intercepts, which we said was negative 1.3 approximately, and negative 2.7 approximately. And we also have a y-intercept at 0, 7. So I'm going to approximate that right here. So here's the parabola that's formed by those points. And of course, you got your axis of symmetry, which is x equals negative 2. So that should split it up in half. I didn't draw that as well as should have been drawn. So it doesn't look like it, but it should split in half. All right, let's go to this example. F of x equals negative x squared plus 6x minus 8. Let's go ahead and put that in standard form. So f of x equals, this time we are going to factor out a negative 1, which means that our sign is going to switch right there, because negative 1 times negative 6x is positive 6x. Then we're going to calculate or compute b over 2 squared. So that's negative 6 over 2, which is negative 3 squared, plus 9 minus 9. So that means we have negative 1 times x squared minus 6x plus 9. But I need to take something out, right? So we need to take out this negative 1 times this negative 9. We got to multiply those two. When we multiply that, we get positive 9 actually. So f of x equals, let's keep that negative. We don't necessarily keep the 1. All right, let's go ahead and factor that. That's going to be plus 1 on the outside. So that's x minus 3 squared. So this is the standard form. What does a equal? Negative 1. Does that mean the parabola opens up or down? Parabola opens down. That means our vertex would be a maximum point. 3, 1, maximum point. So that point 3, 1 right here should be the highest point on the graph. Then for x-intercepts, let's set negative x minus 3 squared plus 1 equals 0. Let's subtract 1 from both sides. Divide both sides by negative 1. Square root both sides. We get x minus 3 equals plus or minus 1. Then we need to add 3 to both sides. We get x equals 3 plus x equals 3 plus or minus 1. So that means we have 3 plus 1, which is 4, and we have 3 minus 1, which is 2. So we have two x-intercepts. The x-intercepts are 4, 0, and 2, 0. So let's go ahead and plot that. 4 0 and 2 0. Now, where does this graph cross the y-axis? We're going to plug in a 0 for x. I like using the general form for the y-intercept. So our y-intercept is 0, -8. So somewhere, actually 6, 7 down here, right? So when we plot the points, we're going to connect all of these dots. There you go. Write the standard form of the equation of the parabola whose vertex is 1, 2, and that passes through the point 3, -6. Here's what we know. We know we have a parabola. So we know the function is a quadratic function. We also know the vertex, 1, 2. So we also know that that's h and k. And we also know that this parabola passes through the point 3, -6. So we know that this is x, y. So let's first start by writing out the standard form of the quadratic function. F of x equals a times x minus h squared plus k. Let's first put in the first piece of information. Let's put in the vertex. So f of x equals a times x minus h is 1. K is 2. So we're halfway done. Only other letter we need to replace is the A. So we need to use the last piece of information to solve for A. And we would have constructed the standard form of an equation that represents this information. So we have f of x. Now, f of x is the same thing as y. So we're going to replace that with -6 equals a times x, which is 3, minus 1 squared plus 2. Where did we get that information? Right over here. It was given to us. Then we're going to solve for a. So what I'm going to do now is that's a times 4 plus 2, which is 4a plus 2. Let's subtract 2, get -8. -8 equals 4a. Divide by 4. A equals -2. Therefore, our function, just go back to step 1, our function is -2 times x minus 1 squared plus 2. This is how you start with information, plug it into the standard form to get the standard form that represents that information. And of course, you can go through all the things, what is A, the vertex, and so forth. All right. Let's move on to this last problem here. Maximum revenue. The total R earned in thousands of dollars from manufacturing handheld video games is given by RP equals -25 P squared plus 1200 P, where P is the price per unit in dollars. Find the revenues when the prices per unit are $20. So when the revenues, so R must represent revenue, right? And you see that P is representing the price per unit. So if it's telling us the price per unit, then these must be the P's, all right? So our function is R of P. Let's go ahead and put R here of P. So R of $20 would be -25 times 20 squared plus 1200 times 20. All right. So we put this in our calculators. -25 times 20 squared plus 1200 times 20 is what? So this is 14,000. But notice that it says that total R earned is in thousands of dollars. Total R. So that means we're going to multiply this times 1,000 to get the real answer. So $1,400,000 if we sold this video game at $20. What if we sold it at $25? Will our revenue go up? Well, let's see. So plug this into your calculator again to see if the revenue goes up. Up here, I'm just not realizing this is really 14 million, right? All right. And this 14,375,000. That's what it really is. Now, if we sold this handheld video game at $30, will our revenue go up? Let's see. No, it doesn't. It's 13,500. And if we multiply that times 1,000, what do we get? 13 million. So we kind of lost money because we were beginning to sell this game too high, and consumers decided they weren't having it. They're not going to buy it for $30. It was too much for them. So it went down. So if we graph this information or attempted to try to graph it, let's say this was 5, 10, 15, 20, 25, 30. And let's say this is price per unit down here. And let's say this is revenue this way. So 13 mil, 14 mil, 15 mil. Okay. And then if we try to plot some points, well, we know at 20, it was doing something like 14 right here. It's right here. But at 30, it was starting to go down though. All right. And then 20, 25 was okay. 25 was here and 20 was here. So it's doing something like this, right? It's a quadratic. We know that our A is negative 25, so our parabola opens down. All right, so here's what we want to know though. Okay, 25 is here. We want to know because we don't know we want to know what is the maximum point because that's going to tell us we don't know yet, but we can figure it out, right? Because we know how to find the HK from a quadratic function in general form. So we want to know that because how much should we sell this video game for to receive the most revenue? That's what we want. All right, so let's put this form right here, R of P equals negative 25 P squared plus 1200 P in standard form. So that would mean we'll need to factor out that negative 25. So let me divide 1200 by that 25. So that'll be minus 48p. Then we're going to still do our negative 48 over 2 squared, negative 24 or negative 24 squared, which is 576. So that's R of P equals negative 25 times P squared minus 48P plus 576 minus 576. And then our perfect square trinomial is right here. So we're going to take this out right here. So negative 25 times p squared minus 48p plus 576, what are we really taking out? When we multiply 576 times 25, get this 14,400, which tells us, gives us information about our HK here. So we have P minus 24 squared plus 14,400. And again, we have to know that yes, this is our H right here. This is our K. However, we need to multiply that times 1,000 for the revenue part. Okay. So our vertex is, let's sell this video game at $24, and it's going to give us a maximum of $14,400,000. This is what we want. This is valuable information for a company. What is the price point? What price point should we sell this product at so that we can get the most money? All right, here is just a shortcut way to find the vertex. The formula is this: negative b over 2a for your x, and for your h, you will just plug in that x back into the function. For example, x is negative b over 2a. So let's go back to the original problem, which is r of p equals negative 25 p squared plus 1200 p. Okay. Oh, I actually should have put that there. All right, so in this case, our b is this, right? So that would be negative 1200 divided by 2 times a, which is negative 25, which is 1200 divided by 50, right? And we did this already. These numbers look familiar to us. That's 24. See how we got the 24 already? That's your first coordinate of the point HK. And then you just plug that into the function R of 24. What would that give you? 24. So you're evaluating the function at 24. So that's going to give you that 14,400. But of course, we know we need to multiply that times 1,000, right? To get the 14,400,000. So that's a shortcut way to get to the vertex for any function.